If you look at BYD, which most people have never heard of, if you count all the manufacturing space they have in China to make cars.
I don't think anywhere in the history of the automobile has any company enjoyed such explosive growth in such a short period of time.
The CEO of BYD, Wang ChuanFu, has announced a game-changing new engine that may alter the fortunes of the electric vehicle world. Tesla is widely regarded as one of the leading EV makers on the globe, but this corporation has begun to see its long-term dominance challenged in its biggest market, the China EV market, by rapidly growing local players with relentless pressure on prices. This move sends shockwaves in the industry with the strategic shift of BYD from pure electric innovation to state-of-the-art engine technology. And this bold, challenging step can be a new start for future automotive technology in general. What does that mean for the EV sector and therefore sustainable transportation? Join us as we explore the latest groundbreaking creation from BYD that's going to shake up the electric vehicle industry. But what makes this new engine so revolutionary? Could it really be the game changer that pushes BYD ahead of Tesla and other industry giants? Let's dive into how this engine works and why it might just be the future of the EV industry. The future of the EV industry is here. Presently, the automotive sector seems engulfed in the trend for electric vehicles in view of the great move towards cleaner, more environmental sources of energy. Due to the growth of the electric vehicle market, one can witness growth in voyage journeys towards optimum transportation. Such stumbling blocks include the problems resulting from a range of inadequacy, scantiness, and length in terms of charging time. Given drivers requiring extended ranges are many. BYD has been one of the frontrunners in EV development and recently introduced a completely new direction that may change our perception of electric mobility. The just-announced engine of BYD CEO Wang ChuanFu is a revolutionary unit that bridges the divide between electric and traditional power plants, taking the best from each in one bold stride. A bold stride challenging many assumptions regarding electric vehicles. Being considered one of the pioneers in EV technology, BYD has been pushing the envelope for a long time, competing with other firms like Tesla Rivian and more established automakers such as Ford and GM. These companies have invested a lot in electric propulsion systems, and the trend seems to be going toward full electric solutions, abandoning combustion engines. The EU has proposed a ban on selling new combustion engine cars by 2035. However, the latest move by BYD upsets this tempo somewhat unexpectedly. Instead of fine-tuning its EV technology as many had expected, the leadership of BYD has opted for an entirely new approach, one that combines some aspects of electric and combustion power. According to industry analysts, the shift might be transformational for the sector. But what exactly makes BYD's new engine so different from everything we've seen so far? Could this hybrid powertrain really be the solution to the EV industry's biggest challenges? Let's break it down and see how it's pushing the boundaries of what's possible in automotive technology. What's different about this engine from the rest? Early indications are that BYD's newest creation outpaces most electric vehicle powertrains on the market today. The breakthrough technology combines the efficiency of electric motors with range and refuel times akin to those offered by combustion engines. A system like that would eliminate the anxiety of many EV drivers and could accelerate wider acceptance. The automotive sector has long been divided between electric motors and internal combustion engines, but BYD's approach offers a middle way that may change vehicle propulsion. Traditional battery electric vehicles boast excellent efficiency, but are really plagued by long charging times and frequent recharging stops during long trips. The BYD concept rethinks this paradigm, perhaps into a new form of hybridization in which electric and combustion components play to each other's strengths. This announcement has sent the whole auto fraternity into a tizzy, with most experts voicing emotions running from skepticism to excitement. Many are keenly waiting to see whether BYD's hybrid engine can really live up to its tall claims. If it does indeed work out, that will be game-changing and will shake the entire EV market, stirring new technological explorations. Companies have been improving the battery's technologies all these years to increase the range and decrease charging times. While incremental advancements have been made, none have fully addressed the limitations in a way that would make EVs as convenient as gas-powered cars for all drivers. It's BYD's vision to merge the best qualities of both systems in a way that challenges the industry to change course and positions BYD on the leading edge of perhaps the new order for future vehicles. It is a step ahead of what BYD had been offering, but not necessarily a deviation from its all-electric roots. It would appear that the new engine is one of the bridges that could create various forms of sustainable propulsion, positioning BYD as a leader and not merely a competitor in the EV market in terms of driving clean, efficient and powerful vehicles. By targeting the very limitations that have held EV systems back, this could be the hybridized technology to reboot sustainable transportation and make EVs more palatable for the mass market. As the world accelerates towards clean energy, such technology can help accelerate it. In a market that has seen EVs as the future and internal combustion engines as the past, BYD's innovation is a compelling reminder that there's still scope for reinvention, nay, re-engineering. New engine technology developed by the company promises to be quite different from the binary approach that has been chased up till now, of electric versus combustion, to an integrated approach, which might finally flip the conversation in the world of automobiles. With its latest pioneering engine, BYD moves from an either-or paradigm to an approach of and, incorporating the best power sources. If successful, this BYD hybrid engine would represent the beginning of that future wherein EVs no longer must be shackled to their batteries and can offer both the power and efficiency desired by drivers. This opens up more choices for the consumer, with fewer trade-offs, while calling upon innovation for the industry to rethink what clean mobility really means. It will pay off in the form of the gamble taken by BYD and open an entirely new frontier within the automotive industry. That said, the potential may not be less than revolutionary. But how exactly does this hybrid engine work in practice? What makes it so beneficial for the future of transportation? Let's explore how BYD's groundbreaking innovation could redefine what consumers can expect from their vehicles. How beneficial is the hybrid engine of BYD? The BYD hybrid engine represents a groundbreaking innovation for the electric vehicle sector, opening ways to more convenience and sustainability for consumers. During the past years, fully electric vehicles and traditional internal combustion engines have shared the automotive market, each having its own positive and negative points. The BYD hybrid engine closes this gap, marrying electric propulsion efficiency with the range and familiarity of combustion power, letting the electric vehicle industry cash in on benefits previously inaccessible. Arguably, one of the most profound benefits of a BYD hybrid engine for the electric vehicle sector is its potential to bypass some infrastructure deficiencies. Electric cars are extremely dependent on widespread networks of charging stations, many of which are underdeveloped in many parts of the world. However, the BYD hybrid engine lets the drivers combine electric and traditional fuel to avoid the problem of the accessibility of charging stations. Gone are the days when drivers had to have the stress of being stuck somewhere without a charging station, especially in the countryside or rural areas. This flexibility will facilitate the adoption of electric vehicle technology in regions with thin charging networks, hence opening up the electric vehicle market significantly to consumers. The BYD hybrid engine tackles two major concerns: range anxiety and charging duration. While modern electric vehicle batteries have improved in their range, they still remain very dependent on the capacity of the battery and charging points around. The hybrid engine gives drivers the benefits of electric driving, but with the security of knowing they can fall back on traditional fuel if needed. It can also make electric vehicles more relevant and desirable to many customers who highly prize convenience and versatility. Finally, long-distance travel is significantly less headache-inducing. No tedious calculations behind charging stops, and in general, it is going to feel much more like how it has always been for a consumer. Other added advantages for consumers are the possibility that hybrid engines can attain far better fuel economy to save them money. The mixture of fuel and electric power in hybrid engines works together to attain the best fuel economy for a reduced frequency of visits to gas stations, hence enabling customers to control the operational cost of running a car. For many families, the decision to go to a hybrid solution rather than a fully electric vehicle may also be more accessible from a budget perspective, since they will not need to invest in home charging installations or wait for fast charging networks to expand in their areas. The hybrid option allows consumers to get closer to the economic and environmental benefits of fully electric vehicles without the need for a complete lifestyle change. In the BYD hybrid engine, there is a move away from the electric vehicle industry's high dependence on just battery technology. But this push for better and more powerful batteries has also meant a rising tide of concern over resource scarcity, not to mention the impact the mining has on local environments where materials like lithium and cobalt are mined. That could be alleviated as the BYD hybrid does not require large battery packs using such resources. This allows the electric vehicle market to be less constrained by the supply of particular materials, which will make it much easier to scale production, meet growing demand, and not overload resource supplies. It could even take some pressure off the battery makers, who have been racing to increase capacity and speed, often seemingly at the expense of long-term sustainability. Among the most convincing reasons for the BYD hybrid engine are those touching on environmental benefits. While electric vehicles have been lauded for zero emissions during operation, their manufacture, especially mining and producing batteries, carries a great deal of environmental impact. Mining for lithium and cobalt has been linked to habitat destruction, water depletion, and in some cases, human rights abuses. BYD's engine introduces a hybrid system that reduces reliance on large battery packs, thereby potentially reducing demand for mining. This reduces each vehicle's ecological footprint, putting the production process in close alignment with sustainable practices and, eventually, a smaller supply chain that puts less stress on the environment. Besides this, the BYD hybrid engine is able to respond to one of the fast-emerging environmental challenges brought about by the disposal of electric vehicle batteries as their first generations reach the end of life. Battery disposal and recycling have become critical issues nowadays. Current methods for recycling batteries are not capable or equipped to handle the mass recycling of electric vehicle batteries in the near future, thereby wasting concerns and environmental destruction associated with battery disposal. Smaller batteries, on the other hand, could ease BYD hybrid engine recycling facilities and lower the overall environmental impact resulting from battery disposal. This would create a more sustainable ecosystem for electric vehicles, where battery use is optimized and waste minimized. The other environmental benefit could be the influence it has on the general energy infrastructure of the world. Most countries are struggling to scale up their energy grids to meet the mass use of electric vehicles. The BYD hybrid engine allows for a complementary method so as not to strain electricity grids, since cars do not have to rely entirely on them. This will be pretty valuable in countries where the electricity supply is strained, with already heightened demands or areas yet to have sustainable sources. But rather than heavily investing in expanded electric grids, governments and utility companies could work toward a balanced energy infrastructure that can service both electric and hybrid vehicles, offering a more open or flexible approach to green transportation for the consumer interested in sustainable technology, yet leery of the compromises sometimes required with electric vehicles. BYD Hybrid makes it easier to get into eco-friendly driving, where electric cars require several changes to one's lifestyle, from long-distance travel planning around charging points to installing home chargers, among other things. The hybrid engine eliminates most of these problems. Consumers can enjoy the pleasure of reduced emissions without some of the limitations on range and length of charging. This offers a far more approachable, user-friendly way to drive sustainably, and perhaps would attract more drivers to the eco-friendly options when the transition becomes much less daunting than going into a fully electric vehicle. The BYD hybrid engine should stir up more innovations throughout the industry as more manufacturers become aware of BYD's success with hybrid technology. Other automakers might get stimulated and start working in this respect, leading to much variation in green vehicle choices for the consumer. This should trigger competition that will lead to new developments in fuel efficiency and reduction of emissions, making hybrid systems more advantageous. It is thus both a product and a catalyst for the entire industry to think outside the box for a more innovative and flexible future. The influence of the BYD hybrid engine does not stop at functionality, but introduces a whole new paradigm in how one thinks about sustainable transport, consumer satisfaction, and market adaptability. This enables a future in which, by tackling practical, environmental, and industrial challenges that have determined the profile of the electric vehicle market, electric cars can stop being one-size-fits-all and be more about an individual need or preference. As with every innovation, there's always the downside. With how incredibly beneficial the hybrid engine created by BYD is to not only consumers but also the electric vehicle market, What are the challenges and problems encountered by using it? While the BYD hybrid engine offers incredible potential, it's not without its hurdles. What challenges stand in the way of its widespread adoption? And how could these impact its success in the long run? Let's dive into the obstacles that BYD faces as it pushes this revolutionary engine into the market. Hybrid engine challenges and setbacks. The development of BYD's hybrid engine brings a number of challenges and disadvantages to manufacturers and end users alike. Creating an efficient hybrid engine that effectively captures the advantages of electric and combustion technologies is far from an easy task. In the design, production, and rollout phases, substantial technological and financial obstacles have to be cleared by BYD. Hybrid engines introduce unique complexities and issues for consumers, impacting everything from maintenance costs to driving experience. These hurdles affect not only BYD's production processes, but also consumers and the broader automotive industry as a whole. This goes to say that one primary problem BYD has to juggle when developing these hybrid engines is balancing its power output and fuel efficiency. Hybrid engines are in a position to perform on par with combustion engines in terms of power and, like electric motors, in terms of efficiency. Engineers need to find a way to marry both propulsion systems together, carefully calibrating components such as electric motors, combustion engines, and battery systems. It's not always easy to strike that balance. Gains in one area, such as fuel efficiency, are often at the expense of power output or increased emissions. These trade-offs take a lot of testing and re-engineering, which is very time-consuming and costly, again testing BYD's capability to deliver a product that will meet all expectations of performance. High hybrid engine development brings a supply chain complication for BYD. Hybrid engines need a mix of both electric and traditional combustion system parts. Sourcing parts for electric motors, batteries, and combustion engines simultaneously poses a logistical nightmare and only increases production difficulties and costs. The hybrid engines also need additional parts that are particularly special, adding to BYD's pressure to find reliable suppliers and manage inventory efficiently. Supply chain oscillations, mostly those that relate to electric motors and battery parts made from rare earth metals, can increase costs due to production delays. Such disruptions might affect production schedules and add to the ultimate cost, which could hurt BYD's hybrid vehicle standing in terms of competitiveness. Apart from supply chain disruptions, other challenges faced during the course of developing its hybrid engines are that various markets prescribe different regulatory parameters. Since the hybrid engine falls under both emission standards for combustion engines and energy efficiency standards for electric motors, it becomes hard to design a single product to meet all regulatory requirements. Additional tuning of the combustion side may be required in markets that require higher emission standards, and countries requiring high electric efficiency may demand further development either in the battery or the electric motor. These diverse needs may indeed increase the cost of production when BYD is compelled to develop market-specific models or add more technologies to conform to international standards. In terms of the consumer standpoint, hybrid engines have their own set of problems that affect driving and ownership. It becomes pretty challenging to maintain them in particular, since there are both electric and combustion mechanisms that need to be looked after in a hybrid engine. For example, even though most EVs require less maintenance because of having fewer moving parts, bringing a combustion engine in introduces many of the same maintenance tasks again, including oil changes, checkups for the engine, and exhaust systems. Consumers can easily find themselves visiting service centers more often, or having to pay more for car maintenance, as servicing a hybrid engine requires more complex expertise and tools. These can be a problem for drivers who are used to only one or the other type of engine, as both add time and cost to vehicle ownership. Other aspects that might be less pleasing for consumers are the not-so-widespread special infrastructure and service providers for these vehicles, at least in those countries where EVs are still in their infancy. While most of their training is geared towards handling conventional engines or fully electric systems, they do lack training in both fields. With a minimal number of hybrid specialized service centers, consumers can face great difficulties in finding qualified technicians to meet their vehicle needs, especially in areas far from cities. Additionally, because hybrid engines are still a relatively new technology, replacement parts can be expensive and harder to source, resulting in longer wait times and higher repair costs. These factors cause discomfort for consumers and involve higher costs, which may lower the overall attractiveness of hybrid cars. Despite their proclaimed advantages, fuel efficiency, usually cited as a strong point of hybrid engines, may also be a source of disappointment for some users. Hybrids work well in stop-and-go driving, where regenerative braking can help recharge the battery to maximize electric use. In reality, for most customers who drive distances or spend significant time on highways, the electric portion of a hybrid will rarely be put to use. Fuel economy is closer to that of a traditional combustion engine, rather than boasting huge savings promised by hybrids. This may also cause discontent among consumers who were expecting more fuel savings and an added expense for those who believed a hybrid engine would save them a lot in terms of fuel. While generally improved, environmental sustainability has its setbacks with hybrid technology. Hybrids, part of which still run on fossil fuel, thereby do not achieve the zero-emission status of a fully electric vehicle, and thus continue to emit greenhouse gases. While they do emit fewer pollutants compared to their traditional combustion counterparts, hybrids are not as green as pure EVs and may discourage environmentally concerned buyers from choosing them over fully electric options. Besides, the introduction of lithium-ion batteries in hybrid cars introduces problems with mining impacts and disposal. Most of the time, the mining of lithium and other battery materials is accompanied by huge environmental degradation, and since hybrid vehicles are increasing the demand for batteries, the environmental footprint of hybrid production remains an issue. Battery lifespan and replacement costs are further issues that hybrid engine owners may face. Like all lithium-ion batteries, hybrid batteries degrade over time, which negatively affects their efficiency and performance. This fact is of particular concern with hybrids, as they utilize a smaller battery pack than fully electric vehicles. Any loss in battery capacity may thus have a more immediate effect on fuel efficiency and overall performance. When the battery reaches the end of its lifespan, high replacement costs for consumers and, in certain instances, difficulty in locating compatible replacement batteries. If the vehicle model has been discontinued, add more costs and inconvenience to consumers who may not have fully accounted for these expenses when initially purchasing their hybrid vehicle. Hybrid engines bring in complexities regarding performance and driving, which may not be fully anticipated by every consumer. Such is the case in acceleration. A hybrid engine may not give as smooth of acceleration compared to either a traditional or a fully electric engine due to its mode transitions from electric to combustion. This is quite a shock for drivers who are more accustomed to seamless and instant torque delivery than would come with a full battery electric vehicle. Sometimes the hybrids are also heavier and less agile than their respective combustion or electric counterparts, since there is added weight attributed to batteries and electric componentry, affecting handling and responsiveness. It might affect the whole driving experience and could lead to the preference of some consumers for single powertrains over hybrid ones. While hybrids bridge the gap between combustion and fully electric, they present a whole new set of challenges and complications that can impact their broad market reception and penetration. In dealing with these gaps, some deploy mobile technicians. This is completely relying on remote fixes with mobile reps, which risks limiting third-party independent shops. Out of this, manufacturers increasingly collaborate with third-party players more closely through training tools and support. Customers are also worried that vehicle manufacturers might be trying to economize at the expense of some features. Attention is urgently needed because it makes vehicles less dependable, and besides having a short lifespan, it may discourage customers from making future purchases. This could form a vicious circle where companies slash costs without resolving vital problems with quality, possibly eventually dampening customer demand for future purchases of electric vehicles. This might make the transition to greener transportation a bit slower, since customers will still hold quality and trust very dearly when choosing an automobile. What challenges stand in the way of its widespread adoption, and how could these impact its success in the long run? Let's dive into the obstacles that BYD faces as it pushes this revolutionary engine into the market. Navigating the high stakes of owning and maintaining EVs, consumer resistance to electric cars is rooted in a number of factors, mostly hinged on the question of durability and resale value. The big barrier here is the general feeling of people that electric cars are naturally less durable than conventional gas-powered ones. This perception, while perhaps misplaced, goes a long way in affecting the market dynamics for EVs. A consequence of such thinking is that it lowers the resale value for EVs because they are perceived to have shorter lifespans than conventional internal combustion engines. This, in fact, turns this into a self-reinforcing cycle, as those buyers who can consider EVs further abstain from purchasing them due to this reason. Further effects on the overall market include a tough environment where any manufacturer tries to make an entry into electric vehicle manufacturing. Infrastructure is another major obstacle when it comes to the expansion of electric vehicles. All these charging and maintenance facilities in rapid development have not kept up with the demand levels for electric vehicles on the road. This lag can make the transition to electric mobility much more difficult at a point in time when they are not easily able to provide efficient maintenance or charge their own vehicle. Insurance considerations, therefore, are a very important component in their decision-making process when choosing an EV. The costs for repairing EVs continue to rise to alarming levels in many instances, closing in on the price of a new vehicle. It goes to the extent that it is usually economically unviable for owners when this happens, hence a factor that increases the possibility of the electric car being declared a total loss after accidents. The response of the insurance industry to this challenge has been inconsistent. Though some firms have adapted their policies to the peculiar demands of electric vehicles, many struggle with the coverage required. Another layer of complexity in the already not-so-easy landscape of electric vehicle ownership is the disparity in payouts for EV damage compared to conventional vehicles. Recent moves by Ford in the electric vehicle market have sparked intense debate among industry professionals, with some even going on to say that Ford may change the face of car production and repair in its own image. The more things change in the world of automobiles, the clearer it becomes that the standards traditionally used for repair may prove lacking for modern electric cars and their systems. Different solutions have been put forward for such issues. One of the probable ways could be the development of open-source software for electric vehicles. This would allow independent mechanics to compete more easily with service centers tied to manufacturers, which would reduce repair costs and thus make such services more affordable to consumers. Another strategy that is gaining momentum is the right to repair movement. The latter advocacy calls for legislation to provide independent repair shops and car owners with more data and tools necessary to execute repairs. The state of Massachusetts has passed a landmark law to provide an industry-wide in-vehicle standardized data platform, enabling independent shops with owner permission to make such repairs. As the electric vehicle market keeps growing, automakers are increasingly adjusting their strategies. Most of them consider partnerships with independent repair shops and invest in professional assistance programs to help these businesses develop the expertise needed to work with complex electric vehicle systems. This could be the shift toward collaboration that will keep the repair market for electric vehicles competitive. However, despite these, challenges still prevail. High repair costs and complex systems of electric vehicles remain challenges for both consumers and technicians of the profession. A mix of technological development and practical feasibility of repair will no doubt be required if there is to be a long-term future in electric vehicles. It goes without saying that how such a challenge is overcome and how sustainable solutions are found will determine the electric vehicle's future in the best interest of consumers and the environment alike. Moving forward, transparency, accessibility, and environmental responsibility must be continued concerns regarding manufacturing and maintenance in the production of electric vehicles. It is going to be a circuitous route to broad usage of electric vehicles. The benefits of electric mobility make for a very fine reason to continue investing in this area, and hence bringing innovation into the market. As technology progresses, barriers to entry should be overcome with solutions, at least gradually, and provide an opening for a more environmentally friendly transport method. Government policies can either make or break the electric vehicle market. Favorable regulatory frameworks, like tax credits or preferential parking arrangements, greatly increase consumer interest in electric vehicles. On the other hand, policies that discourage the use of electric vehicles, for example high fees for charging infrastructure, can hold them back. Besides, the development of standardization protocols for electric vehicle components could greatly simplify the repair process. This would achieve economies of scale in the production of spare parts and could help reduce repair costs for end consumers. It is quite important to provide education on the benefits and realities that come with the ownership of electric vehicles for consumers. Most of the misconceptions have a basis in either range anxiety or charging time, and therefore overall performance. This will help with the dampened hesitation across the market currently. Thank you for watching this video. Make sure to like and subscribe to get more content like this.